Hi guys. We are proceeding from our previous lesson. Now we are going to do properties of exponents, laws of exponents. We are going to deal with exponents. What have we covered so far? We have covered real numbers. In real numbers we spoke about natural numbers, integers, rational numbers, irrational numbers. We went on to talk about properties of real numbers. There we discussed associative property, distributive property, and commutative property. We also discussed the properties of the negatives, and we defined fractions. We listed the types of fractions and properties of fractions when we were adding, subtracting, dividing, and multiplying fractions. We've done quite a lot of work so far. That covers about 4 topics now. We're now entering into the 5th topic. As you can see, the levels are increasing. We started right at the bottom. Now we're starting to get sophisticated. We're talking about exponents, radicals. Okay, that is what we're going to talk about. Exponents and roots. I always like to define. When we define things, it enables us to gain understanding. Without understanding, we go nowhere. Whilst we are talking about understanding, you must watch my video where I talk about how to use memory. It's important how to use the brain and how to gain understanding out of the work that you do. Especially how not to forget and how to remember fast. Okay. Those are the basics. I'm just giving you basics and I'm simplifying things. Right. So, on this lesson, I am talking about exponents. I hope my pen is writing well. Exponents. It's giving me problems. Okay. Exponents. And radicals. Exponents and radicals. and radicals. Exponents and radicals. Well, my letter D doesn't look so nice. Let me try and correct it. Ah, I leave it. I'm getting the same thing. Okay. Let me clean the pot. All right. All right. So the first thing, I want to define an exponent, and I want to show the exponential notation. A notation is how we write it in a symbolical form, in a mathematical form. So an exponent an exponent, in simple terms, is a number that tells the base how many times it should multiply itself. Firstly, we have a to the power n. This is a base. This is an exponent. Or power power. All right. An exponent is a number. So n will tell the base how many times it must multiply itself. If n is equals to 5, then a to the power 5 is equals to A multiplied by the second A multiplied by the third A multiplied by the fourth A multiplied by the fifth A. Oh. So each and every base has got an exponent 1. You must just remember that. If the exponent is not written, you must know it's 1 all the time. It's like coefficients. Coefficients, most of the time, when they are not written, they are equal to 1. But once the coefficients are greater than 1 or less than 1, we have to write them. So when you don't see the coefficient written next to a variable, you must know that is a 1. So we say an exponent tells the base how many times to multiply itself. Can you think of the opposite of this? How many A's are in A to the power 5? How many A's? There are 5 A's. We'll get to a point whereby we need to discuss something that is opposite to this. We'll ask a different questions. It's about factor, a factor. When we talk about radicals, when we talk about roots. But for now, we're talking about an exponent. An exponent. An exponent is the number that tells the base how many times the base must replicate itself. I think that is clear. You do not, I repeat, you do not multiply a base by an exponent. You don't do that. Otherwise, you are going to have A multiplied by 5. This is wrong. You can't do that. It's totally wrong. I know there are people who do this. So make sure you don't fall into that trap. You must not fall into that trap. We are now going to talk about the zeros and the negatives in exponents. I just want to start with that. Why? Because of the definition. The definition of exponents states that an exponent or a power is a number that tells the base how many times it should replicate itself or multiply itself. So now, what about a power 0 or exponent 0? And what about a negative exponent? What does that tell us? Is it in line with the definition? So, I am talking about zero, and negative exponents. Exponents, negative exponents, and zero exponents. What does that tell us? Well, a to the power 0 is equal to 1. Even if you have $1 billion, $1 billion to the power 0 is equal to $1. Any number, any variable to the power 0 is equal to 1. That is the law. You can't change that. Number 2. We are talking about a negative exponent. We are not allowed to have a negative exponent by definition, because a base cannot multiply itself or replicate itself negatively. Because by definition, a negative number is a number less than 0. So, if any number or any variable to the power 0, it's 1. It's even worse with a negative number. So we have to make this exponent positive, and therefore we are going to use a reciprocal. There you go. Now it makes sense. So if you had a to the power negative 2, you arrange it properly to follow the definition. You'll have 1 over a to the power 2. It makes sense. Let us move on. Let us discuss these laws of exponents. Laws of exponents. So we have number 1. On number 1, we are multiplying two bases. The bases are the same. What happens? Because bases are the same, then according to the law, we will keep the base. That is what you do. You keep the base. Let's keep the base. We bring back the base, and you add the exponents. Number 2. We're still dealing with the same base. We are dividing similar bases. When we divide similar bases, because it's similar bases, we bring back or we keep the base. And we take the numerator exponent and subtract it with a denominator exponent. Number 3. We have a power to a power. A power to a power. So you may have a to the power m to another power of n. In this way, you only have one base, of course. What are you doing with these exponents? They will multiply each other. M multiplied by n. You get a to the power m n. Number 4. You have a product of 2 or more numbers of variables raised to a power. In this case, you may have variable a multiplied by variable b all to the power n. What this means is that a is to the power n times b to the power n. That's what it means. Number 5. We have a fraction raised to an exponent or a quotient. You have a over b all to the power m. All to the power m. This means that a is to the power m over b is to the power m. From number 3 to number 5, I want to explain this, guys. This. We are actually multiplying powers. Why am I saying we're multiplying powers? Here we multiplied n by m by n. And here there is power 1 and there is power 1. And here there is power 1 and power 1. Now you multiply. You take 1 and multiply it by n, by this n. You get 1n. You see? You get 1n, 1n, because of these ones that were not written. Similarly here, you multiply 1 times m, you get 1m. And 1 times m, you get 1m. Voila. There you go. Can you see? We've dealt now with 7 things under exponents. We dealt with a power that was a 0 and is giving us a 1. Anything, any base you can think of to the power 0, it gives us numero uno, number 1. 1, it gives us 1. Any base to the power negative, a negative power or a negative exponent, we have to write it in a correct format, because we are not allowed to have a negative exponent. We are not allowed. You must know that. So we have to use a reciprocal. Of a. So we are going to have 1 over a to the power n. Then the exponent is positive in that case. And we also came to these laws, number 1 up to 5. And I have explained them now. They are straightforward. Number 3, 4, 5, they are the same. You do basically the same operation whereby you multiply the powers. Whereas in 1 and 2, we are dealing with the same bases. When you multiply same bases or similar bases, you have to add the exponents. And when you divide similar bases, you have to subtract the exponents. Don't forget that. Now we are going to do something more challenging. Well, there is a number 6. You have a over b. Now they have a negative exponent. Are we allowed to have a negative exponent? Yes or no? I don't think so. We are not allowed. Why? Because of the definition. How can the base replicate itself negative times? What do we do then? We use a reciprocal. So we are going to have b over a, and then the exponent become positive. I think you can appreciate this now. You see this b over a to the power n. You now know how to simplify it, because it's actually law number 5. You multiply powers. We are now doing the most interesting one, the radicals. 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 In radicals, we're doing something totally different. It's still exponents. It's just that the exponent has changed. We have dealt with an exponent that is a 0. Secondly, we dealt with an exponent that is a negative. Now, we're dealing with a third one, an exponent that is a fraction. An exponent that is a fraction gives us a radical sign. What is a radical sign? It's this sign. This is a radical sign. Okay. So when we have an exponent, that is a fraction, we have something that is different, totally different. So when the exponent is a fraction, you have 1 over n. This 1 over n will automatically give you nth root. If n was 2, we'd say square root automatically. So I want us to deal with something important here. The radicals. The radicals also have rules that may be similar to what we've done in the exponents in terms of reasoning. And those rules are as follows. One, we have AB this means number two, we have This means over number 3. We have root m and n we can multiply m and n. Number 4. We have it means if n is odd, this is the condition. If n is odd, number 5, the last one. We have n equal to absolute value. Okay, we rather not do this. Let me just explain. This. So if n is odd, what does it mean? Let us say we have, let me write it in blue. So let us say we have 3 to the power 5 to the power negative 5 to the power 3. We are going to have negative 5. That is what it means. So if this number is an odd number, is an even number, we have n here, a to the power n. We are going to have a absolute value. What does it mean? It means it's positive if n is even. All right, so we have negative 3 here to the power 4. We shall have negative 3 absolute value equal to 3. Equal to 3. So I have explained the laws of exponents and the radicals. I think this is useful. I have tried to simplify it. We have an exponent, the definition. We have the laws. We have the radicals. There is a logic behind radicals, or the roots. You know, you can ask for a square root of 16. How are you going to get it without using a calculator? You're looking for the square factors that make up 16. If you're looking for the cube root of 125, you are going to look for 3 equal factors that when you multiply, they give you 125. You have to search for that. It's not difficult, it's a simple process. Okay. If you have a problem, you must write me a message. I will answer. I'll answer you. Whatever question you have, I'll answer you. I'll make sure that you gain good understanding. We are now at the end of our lecture. The next lecture, part 3 of Algebra Fundamentals, is going to be on algebraic expressions. You see, I told you, the levels are increasing. We are changing now. We are going to use the laws of exponents, the laws of radicals, properties of real numbers, properties of fractions, types of numbers, properties of negative numbers. We're going to use all that now to construct an expression. On my first lecture on part 1 of Algebra Fundamentals, I said I want to give you a definition of 2 things. A number. What is a number? Number 2, a definition of a variable. That is what I'm going to do on the next lecture. I will be talking about those things. And I'll be talking about how to construct an algebraic expression. You are going to see that mathematics is a language, just like speaking English. Mathematics is also a language. We express ourselves using variables in number operations to express whatever that we need. Guys, please like my page. You can like my video, click thumbs up, subscribe, send to everyone who is doing mathematics so that they can also benefit from the fundamentals of mathematics. My name is JJ Khoza. Thank you very much.